Hello everyone, welcome to today's class. It's me, Teacher Simon, again taking you through Cambridge International AS and A-Level Mechanics, paper 4-1 for May, June 2024, and this is part 1 for questions 1 to 4. Question 1, a car starts from rest and accelerates at 2 meters per second squared for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds, but sketch a velocity time graph for the motion of the car. Now, I need to know that constant speed they are talking about. So we know that acceleration is equal to v minus u over t. If it is given by 2, then we have that fine, then minus 0 over time taken is 2. So when we cross multiply, that means v is equal to 20 meters per second. So this is the constant acceleration. Now I will come here and I will draw this straight line here. Let me draw this one a little bit longer, because there are many seconds taken here. And then next you take this one down just like that. So what do we have here? Here we are having 20. You can label your axis. This is v meters per second, and then this way we have time, which is in seconds, and then here we have 0. Then of course this one here is 10. Then they say then travels at a constant speed for 30 seconds, so 30 plus 10, that one will give us 40. And then uniformly decelerates to rest over a period of 20 seconds, so 20 plus 40, you get 60. So that is the sketch there. Find the total distance traveled by the car. So on a velocity time graph, total distance traveled by the car is the area under the graph. So total distance traveled is equal to total area under the curve. Now this one is a half h into a plus b, because this is the trapezium. Then our height is going to be that 20, the velocity, so 20, and then a can be this one, and then b this one, the parallel sides of the trapezium. So 40 minus 10, that is 30, and then the other one is 60. So 30 then plus 60. A half times 10, a half times 20, you get 10. 30 plus 60, 90. So 90 times 10, this one gives us 900 meters. Question 2, two forces of magnitudes 20 and F act at a point P in the direction shown in the diagram. Given that the resultant force has no component in the y direction, calculate the value of F. This means that the resultant in the y direction is 0. Okay? Remember, when we are solving such coplanar forces, we have to resolve the forces. You have to put this one on the horizontal axis and then also on the vertical. Now, if you have been following me, I've already said that closing in is cosine, then opening up is opening, the other opposite side of the angle given, okay? And closing, you're going the side of the angle. So I always draw something like this. So since I'm closing this one, Then I'll have 20 cos 60. Then opening it up here, we shall get 20 sine 60. Then this way there is f. Okay. So if the resultant force has no component in the y direction, that means Fy, or the resultant in y, is 0. So in other words, F is equal to 20 sine of 60. Okay, this one is going to be 20. Then sine of 60 is the same as root 3 over 2. And this one will give us 10 root 3. So I can just leave it there, or I write 17.3. The three significant figures. Then part B, given that F is equal to 10, find the magnitude and the direction of the resultant force. Now, our resultant force, we need to know, if I put 10 here, okay, 10, already we have seen this one is 10 root 3, so it is bigger than this one, so that means the resultant in y is acting upwards, okay? The resultant in y is acting upwards. So we shall have our simple diagram here. So the resultant in y will be acting upwards, and then the resultant in x, of course, is this side only, because we don't have any other opposing force. So we shall have our fx here, the resultant in x. Then there is fy here. You can use ry, you can use rx, and then the resultant has to be here, which is the resultant force altogether. So we need to know the angle here it makes with the horizontal. Now, of course, if I shift this one and I put it here, because they are parallel, this is the fy, this is the fx. So we are having a right angled triangle here. So to get the magnitude, I use Pythagoras theorem to get the length here. You see? So that is that. Now, let's begin. So our resultant force is going to be, in x, I'm going to write it as a vector. Fx is going to be that 20 cos 60, 20 cos 60, and then the one in y is going to be that it is going up, so 20 sine 60 minus the 10. Okay, now after that, if I want to get the resultant force, it is going to be the square root of 20 cos 60. Cos 60 is a half, so that will be 10 squared. And then 20 sine 60, that one is going to be 10 root 3. Then minus this 10 here, then we square. So we put everything in the calculator. Square root of 10 squared, then plus 10 root of 3 minus 10, then bracket squared. 12 point the rest of those figures, but the three significant figures, our RF is going to be equal to 12.4 newtons. These are three significant figures. So that is what we have there. And then the direction So here I'll have tan of theta, which is equal to the opposite Fy over the adjacent Fx. So theta is going to be the arctan. Fy is actually this one here, the one down, and then Fx is this one here. In fact, let me represent it like this. For x, we resolved horizontally, okay? That is our fx. Then for y, we resolved vertically. That is our fy. So fx here is 10. I mean fy is 10 root 3 minus 10 out of 10. The 10, of course, will cancel. So putting this one in the calculator, we get the arctan of root 3, then minus 1, I think over 1, yes, because 10 cancels, so that will be 36.2 to 3 significant figures. So we can write direction, this is how you write it, 36.2 degrees, that is to 1 decimal place, above, okay, 36.2, above the positive x-axis, the positive x-axis, because it is here, it's above. So that is that. Question 3. A train of mass 180,000 kilograms ascends a straight hill of length 1.5 kilometers, inclined at an angle of 1.5 degrees to the horizontal. As it ascends the hill, the total work done to overcome the resistance to motion is 12,000 kilojoules, and the speed of the train decreases from 45 meters per second to 40 meters per second. Then find the work done by the engine of the train as it ascends the hill, giving your answer in kilojoules. In mechanics, we have to master the art of drawing. So something small here to draw. Maybe this is the train. It is down here. Then there is this angle 1.5 degrees. Now I'm going to use the energy method here. So because that is 90. Then here I have the height. So as it is starting here, since there is speed, which is 45 meters per second, that means here we have kinetic energy. Then it moves 1,500 meters, which is the same as 1.5 kilometers. Okay. Then it reaches here and it has speed 40 meters per second. So this therefore implies that there is kinetic energy here because there is speed, and there is also potential energy here because of the vertical height generated. Okay. Here we don't have potential energy because we are on the ground. It is just starting to move. In other words, it is our point of reference. Now, using SOHCAHTOA also, sine of 1.5 degrees is going to be equal to the opposite, which is h, out of the hypotenuse, which is 1,500. That means the vertical height generated is going to be 1,500 sine of 1.5 degrees. Okay, so our h here is 1500 sine of 1.5 degrees. Now, using the work energy principle, we have work done by the driving force work done by the driving force or applied force. This is the force that is supposed to be there until the particle reaches somewhere. You have applied it there. It has to take the particle, but not when you project the particle and it just falls on its own. So in such a case, the driving force is 0 minus work done, okay, work done against resistance, work done against resistance, then this one will give us the change in mechanical energy. Okay, why do we have something like this? It's because as this one is going up, okay, it is applying a force to go up. So there is work done against the driving force. I mean by the driving force. But then there is resistance to the motion. As there is resistance to motion, this one reduces that work that you are putting there. That's why we put minus. But then also in the process, there is change in the energies here, mechanical energy, whereby we can see potential energy being generated, then kinetic energy is also changing. So that's why we are saying is equal to change in mechanical energy. Now, substituting, we can get work done by the driving force, the one that we are looking for, minus work done against resistance. I think it was given. The total work done to overcome the resistance to motion is 12,000 kilojoules. So we have 12,000 kilojoules, so it has to be in joules. Then change in mechanical energy, we shall get the final. In the final mechanical energy, you should know that it is potential energy, gravitational potential energy plus the kinetic energy. And potential energy is given as mgh. Kinetic energy is a half mv squared. Okay, then this one is going to be now mgh. M is 180,000, then the g is 10, and then times h, which is 1500, then sine of 1.5, and then we have the kinetic energy, which is a half m then v, final velocity. So that's squared. Then we shall subtract. This is our final. Then the initial, we only have the kinetic energy. So a half times 1800, then times 4. I must have written something wrong here. This is 45 here. Pardon me here. This is 45 down here. 45 meters per second. So I'll have here 45 and then squared. Then the rest is just the work of the calculator. So meaning our work done by the driving force, this one will go this side. So we shall have 1200000, then plus let me write 18000 times 10 times 1500. This one is, how many zeros do we see here? 1 2 3 4 5 6 7 8. So 27 and 8 zeros. Then sine of 1.5, okay, 1.5 degrees, and then plus Then this one here, 0.5 times 18, and the 4 zeros times the 40 squared. Okay, that one gives us 144 and 6 zeros, 144 and 6 zeros. Then we subtract. How about if we change this to 45? That is 18225. 18225. And the zeros are how many? They are 4. 1, 2, 3, 4. So now everything in the calculator: 1, 2, 0, 0, 0, 0, 0, 0, then plus 27, 80 zeros: 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, then sine 1.5, then plus 144, 0, 0, 0, 0, 0, 0, minus 18225, and 4 zeros. And this one gives us 44426 to 4442770, 4427760.43. Okay, now they said we give the answer in kilojoules. That means we shall divide by 1,000. So this will be 1, 2, 3. So that one will give us 4427, then 0.76. So we shall have 447.76 kilojoules. Or you can write this one to 3 significant figure and you say 4. There is actually another 4, I think. Yes, there are 3 4s. So there is another 4. So I can write 44400 kilojoules to 3 significant figures, like that. Question 4. A car of mass 1,700 kilograms is pulling a trailer of mass 300 kilograms along a straight horizontal road. The car and the trailer are connected by a light inextensible cable which is parallel to the road. There are constant resistances to motion of 400 newtons on the car and 150 newtons on the trailer. The power of the car's engine is 14,000 watts. Find the acceleration of the car and the tension in the cable when the speed is 20 meters per second. Now, let me do some simple sketch here. Maybe this is the car. Okay. Then there is a trailer here. So they are connected by a cable. So there is tension here generated. The same tension that pulls the car behind is the same tension that takes the trailer forward. So this is the trailer and this is the car. Now, there is resistance to motion of the car, which is 400 newtons, and the resistance to the motion of the trailer is 150 newtons. Okay, then there is, of course, a driving force on the car. Now, we should know that power is the rate of doing work. Okay, force times distance over time. But distance over time is speed. That means we can have FV. So meaning the driving force here is going to be the power which is given as 14,000 watts. Then we divide by the speed, which is 20. And this one will give us 700 newtons. We have our F, which is equal to MA. So the forces that are acting on the car, we can see the driving force The driving force is 700. Minus the opposing forces, we have the tension and the 400 newtons. Then this one is equal to the mass of the car, which is 1700, and then times the acceleration of the car, which we don't know. And then when we look at the trailer, okay, for the trailer there is tension, then minus 150 newtons, then is equal to 300, because the mass is 300, then A. Now, solving this simultaneously, I can just add to eliminate the tension. Okay, and just add to eliminate the tension. Now, I'll have 700 minus 400, that is 300. Now, 300 minus 150, this will be 150. And then this other side, when I add, we shall get 2000 A. So meaning A is going to be equal to 150 over 2000. Okay, and that one simplified, 150 out of 2000 will give us 3 out of 40, or 0.75. So 3 out of 40 meters per second squared. Now, after that, remember they told us to find the acceleration and the tension. So the tension, I can substitute in any of them. Tension is therefore going to be the 300. I'm using this one here. You can use any of the two, okay? So 300 times A, which is 3 over 40, then plus 150. So this one times 300, then plus 150, it gives us 172.5. So the tension is equal to 172.5 newtons. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.